Hi kids, now we'll be going with this paper discussion. You can look into the first question. The first question says, a bar magnet with a magnetic moment 5 SI units is placed in parallel position relative to the magnetic field of 0.4 Tesla. The amount of required work in turning magnet from parallel to anti-parallel is how much? So they said initially it is like this, magnetic field and magnetic moment are parallel. So when you go with that analogy, potential energy will be turning out to be minus m bar dot b bar, both are in the same direction. So m bar dot b bar will be m into b into cos 0 is 1. So minus will be coming. So initial potential energy is minus mb. Now finally magnetic moment and magnetic field are in the opposite direction. So dot product will be m into b into cos 180, which is minus 1. So this is the final minus 1 into minus 1 plus 1. So final potential energy. So what is the change in potential energy? Change in potential energy is final potential energy minus initial potential energy. Final potential energy minus initial potential energy, which is 2 times of mb. M is given in the question 5 SI units, B is given in the question 0.4 SI units. So when you substitute, you will be getting the answer as 4 SI units. So whatever work we are doing, that is going as change in potential energy, right? So answer will be option 1. Now going to the second question. If a source of electromagnetic radiation has power 15 kilowatt, that is 15 kilojoules per second, produces 10 power 16 photons per second, then the radiation belongs to which spectrum? So how many photons per second? 10 power 6 photons per second. How much energy per second? 15 kilojoules energy per second. So for each photon, how much energy? So for 10 power 6 photons, 15 kilojoules of energy. So for one photon, the energy will be 15 kilojoules by 10 power 6. So this much energy, this much joules of energy for one photon. But for one photon, how much is the energy? If you in terms of frequency, h into f, h into f. So h into f will be this much. This much is how much? 15k by 10 power 6. Sorry, this is 10 power 16, right? Yeah, that is 10 power 16. Sorry. So 10 cube by 10 power 16 will be 10 power minus 13 by h value is 6.63 into 10 power minus 34. Anyway, you can approximately do the calculation. You can go with 6.5 into 10 power minus 34 or 6. So you will be getting this much frequency, which is which belongs to gamma radiation frequency. If you want, you can calculate the wavelength also, but if you remember frequency, then you can get it easily, right? So gamma. So for second question, answer will be 3. So for the third one, the amplitude of 15 sine 1000 pi t is modulated by 10 sine 4 pi t signal. The amplitude modulated signal consists of which all frequencies? So there will be 3 frequencies generally it consists of. So what are those 3? Yeah. So what is the carrier wave frequency? Yeah, this is the carrier wave. So carrier wave frequency will be 2 pi f will be this thing, right? So which will be 500. So what is modulated frequency? Then it is 2 pi into f equals to 4 pi. So from here you will be getting 2, from here you will be getting 500. So what all frequencies will be available? It's like fc minus fm and fc plus fm. There will be 3 kinds of frequencies available. fc minus fm. So 500 minus 2, 498. The other one is 500. The other one is 500 plus 2, 502. So these 3 will be available. So answer 2, ADE. Answer is 2. ADE. So answer is 2. Going to the next question. As shown in the figure, 70 kg garden roller is pushed with a force 200 at an angle 30 with the horizontal. The normal reaction on the roller is. So that's the question. So basically, how much force you are applying? You are applying 200, and the weight is given as 7 kg mass. So 700 Newton, 1770, right? It is 70 kg mass. So 70 into g, 700, right? Now, when something is in equilibrium, net force along any direction must be 0. So better option is resolve the forces along 2 mutually perpendicular direction. So the 700 is already this way. So I'll be resolving this one into horizontal and vertical. So horizontal will be 200 cos 30. 200 cos 30 will be, cos 30 is root 3 by 2. So you will be getting 100 root 3. Vertical component will be 200 sin 30, which will be 200 into 1 by 2 equals to 100. Now vertically, this is 100, this is 700. So it is 800. So if this is 800 in this direction, then the normal will be balancing that 800. So normal will become equals to 800. So the answer is going to be option 3. Option 3. The next one, initial speed of projectile is u. At the highest point it is root 3 by 2 u, the time of flight of the projectile. initial velocity is u, and at maximum height it is root 3 by 2u. So at the topmost point velocity is going to be only horizontal, and horizontal component is going to remain same. So what can I say? If the angle is theta, then I can say u cos theta is root 3 u by 2, because horizontal component is going to remain same. So from here I will be getting theta is 30 degrees. So this angle is 30 degrees. So vertical component is going to be u sin 30, which is u by 2. Vertical component is going to be u sin 30, which is u by 2. Now if I know vertical component, time of light will be 2 times of vertical component by g. Vertical component is u by 2. So total time of light will be u by g. Spherical insulating ball of spherical metallic ball of same size of mass are dropped from same height. So which one is going to reach first? Now insulating ball won't be affected. Insulating ball won't be affected. So it will be coming more quickly. What will happen to spherical ball? In spherical ball, what will happen? It will be moving in under the influence of Earth's magnetic field. So suppose let me say like the field lines from Earth are coming in the upward direction. So what will happen? When it comes closer, the flux will be increasing. So if the flux is increasing, it will try to decrease the flux. It will try to create the flux in the opposite direction. So if Earth is behaving like North Pole like this, then the induced currents will try to behave like North Pole like this. So there will be repulsion between them. So if there is repulsion between them, what will happen? The metallic ball will be coming little slower. Because of the eddy currents, there will be kind of repulsion. So it will be coming slower when compared to insulating ball. So insulating ball will reach the Earth first when compared to the metal ball. A free neutron decays into proton and electron generally, but a free proton does not decay into neutron. See, if there is free neutron, neutron mass is more and it can decay into proton and electron, and it can release some energy, because energy mass is equivalent to energy, right? So energy conservation must be valid. So parent mass must be greater than like daughter's mass if you are not giving any extra energy. So nucleus mass, neutron's mass will be converted as proton's mass plus electron mass plus extra energy. But can that happen in the other case? Can the proton decay into neutron individually? No. But if it is a part of a nucleus, then it can take energy from elsewhere. So if proton take energy from elsewhere, then you will be having more energy in the sense more mass. Then it can be converted into neutron. Proton can be converted into neutron if it takes energy from elsewhere, but isolated proton can't be converted into neutron. So what is the reason? Neutron has larger mass. The effect of increase in temperature on number of electrons in the conduction band and resistance. So what will happen? If you increase the temperature, then the average energy of the electrons will be increasing. If the average energy of the electrons will be increasing, then the electrons can easily jump into conduction band. So if the electrons can easily jump into conduction band, the current can be conducted easily. If the current can be conducted easily, then the resistance is getting reduced, right? So number of free electrons increases and resistance decreases. The next question, the maximum potential energy of a block performing SHM is 25 joules. A is amplitude. So at A by 2, what is the kinetic energy? So what is the maximum energy? Maximum energy will be half k A square, which is the maximum potential energy at the extreme position, which is given as 25 joules in the question. Now when it is at A by 2, then the potential energy is half k into A by 2 whole square, then the rest will be going as kinetic energy half mv square. But total energy must always be constant, which is equals to half k A square. So total energy is half k A square at the extreme position. Now at this position, this is the potential energy, this is the kinetic energy. Now I need to modify it and I need to find this. So half mv square will be, when I take it to the right hand side, I will be getting 3 by 4 times of half k A square. But half k A square, I know it has 25. So when I substitute it back, I will be getting 18.75. So what is the kinetic energy here? At this position, it is 18.75 joules. Right. So what is the answer? Answer is going to be option 3. The pressure of the gas changes linearly with volume from A to B as shown in the figure if no heat is supplied or extracted. So delta Q is 0. Then the change in internal energy. So generally internal energy will be given by NCVT. So CV is F by 2R, but they never mentioned about what is happening here. So instead of going by this way, we will go with the other way. The other way is energy conservation. So first law, delta Q equals to delta U plus delta W. They said this is 0. They asked you to find this. So delta U equals to minus delta W. So if I can find what is the work done, then negative of that is going to be the answer. Now how to calculate work done? Work done will be integral P dV. Now what is happening here? It is going from here to here. So volume is reducing. So if volume is reducing, what will happen to the work? Work will turn out to be negative. So if work turns out to be negative, negative of negative is going to be positive. So change in internal energy is going to be positive. Let us calculate what is the work done. What is this? This is area under the graph. So I'll be finding the area under the graph. So I am dividing into rectangle and triangle. Rectangle area is going to be length into breadth, or this is 10 kilopascal. So 10 into 10 cube. What about this? This is 150 into centimeter cube. Centimeter cube is 10 power minus 2 whole cube, 10 power minus 6. 150 into 10 power minus 6. P delta V, or area. Now what about this? This is half into base into height. Half into base is the same thing into height. What is the height? 40 into 10 cube. So this will turn out to be 3, this will turn out to be 1.5. So what is the work done? Magnitude wise it is 1.5, but we know it is negative. So work done will be minus 4.5. So minus of minus is going to be plus. So change in internal energy is going to be plus 4.5. Option 4. Electric potential of a charged spherical conductor. See, whether it is solid or hollow, if you give a charge, it will come onto the surface. If it comes onto the surface, it is going to behave like a spherical conductor in terms of field or potential. Shell, spherical shell. So what about the potential inside? Potential inside everywhere, field everywhere inside will be 0. So potential everywhere inside will be constant, which is equals to kq by r. And outside it is going to behave like a point charge, right? So inside it is constant, which is same as at the center, kq by r when it is inside. When it is outside, it is going to behave like a point charge. So when it is inside, it is constant kq by r. When it is outside, it is going to behave like a point charge, which will be inversely proportional to r. Okay, assertion. The beam of electrons show wave nature and exhibit interference and diffraction. Yes, that's correct. Davison-Germer experimentally verified the wave nature of electrons. That's the experiment what we have in textbook to show, to convince ourselves like electron is going to behave like wave nature, right? So assertion is correct, reason is correct. Based on this reason only, we understood electrons are going to perform like wave nature. So correct explanation. Yeah, so both are correct and it's correct explanation. Option 4. So the next question, the drift velocities for a conductor is Vd. The conductor is now replaced by another conductor with same material and same length, but double the area of cross section. Voltage remains same. The new drift velocity. So drift velocity, when I see drift velocity, I will be going with this formula, equals to NAVD. I is V by R. Now resistance is rho L by A. Now A and A will be getting cancelled. I can see like drift velocity. Remaining things are same. They said voltage is same, length is same, this is same because material is same. So it is not changing. Only area is changing. It doesn't depend on the area thing. Or else you can go with the direct formula. So E depends on V and L, which are not changing. So it doesn't change. So drift velocity doesn't change when you are changing the area. So it will be Vd only. At a certain depth below the surface, acceleration due to gravity becomes 4 times at a height 3r from the surface. So you need to find what is the depth. So field inside the earth is gm by r cube, where r is the radius of the earth and small r is the distance from the center. So if from the center the distance is r, so from the surface if it is d, then what is the relation? It is like this total is r and this is d, so this will be r minus d. So instead of this I can put it as r minus d, where d is the distance from the surface. This is the distance from the center, this is the distance from the surface. Now inside it is like this, but outside it's much easier. You can replace with a point mass, right? So 4 times of at a height 3r from the surface. 3r from the surface is 4r from the center. So gm by 4r from the center square. So I need to solve it. Now what I am doing, I am dividing this with r. I am taking 1 r and I am dividing. So I will be getting 1 minus d by r. Gm by r square will get cancelled. Remaining thing is 1 by 4. When I do the calculation, I will end up with d equals to 3 by 4 r. R value is given in the question. When you substitute, you will be getting 4 1s are 4, 16s are 16, 3s are 48, right? If 1000 droplets of water of surface tension having same radius combine to form a single drop, so what is the energy released in this process? So what is happening? 1000 small drops are combining and becoming one big drop. So volume will be same. So volume of 1000 small drops equals to one big drop. From there I will be getting the radius of relation between radius of new drop to old drop. So bigger drop is having 10 times the radius of the smaller drops. So what about the energy? Surface energy will be surface tension times of surface area. But how many such drops are there? 1000 are there initially, but finally there is only one drop. So surface tension into 4 times surface tension into surface area is 4 pi r square. But this is the new radius. Now you need to see what is the change in energy. So initial potential energy minus final potential energy. When I do that, T into 4 pi r, okay, this r is 10 r, right? So when I substitute, I will be getting 100 into T into 4 pi small r square. So this is 100, this is 1000. So I will be getting 900 into T into 4 pi small r square. This T value is given. They are asking us to take 22/7. Radius value is given. When you substitute, you will be getting this much. So you can see this much energy is getting released, this much surface energy is getting released. So what will happen? The formed drop will be having more temperature. So if you go by the opposite way, if you break one big drop into many small drops, the small drops will be having lesser temperature. That's the reason we'll be feeling like cold while showering when compared to normal. A rod with circular cross section and length is wound uniformly with 400 tons of an insulated wire. If a current 0.4 ampere flows in the windings, the total magnetic flux produced inside the windings is 4 pi into 10 power minus 6, the relative permeability of the rod. Okay, so magnetic field generally will be given by mu into Ni. If no material is there, then it will be mu naught Ni. But because of the material, what will happen? Extra magnetic field will be created because of the alignment and stuff. So mu will be mu r into mu naught. That will be coming from here, right? Relative permeability is given by mu naught. Anyway, so mu will be mu r mu naught. But we need flux. So flux is going to be magnetic field into area thing. But you need to find this. Remaining values are given. So mu r equals to, sorry, this is flux. Flux by mu naught Ni into A. This value is given in the question. This value, you know, this value number of turns per unit length. Number of turns are 400 and length is 40 centimeter. 40 centimeter is 0.4 meters. So number of turns by length. So number of turns per unit length. Current is 0.4 amperes. Area is given 2 centimeter square. Centimeter square is 10 power minus 2 whole square, which will be 10 power minus 4. When you do the calculation, you will end up getting 125. So gamma dependency on temperature. So Cp by Cv is gamma. What about Cv? Cv is F by 2 or degrees of freedom. So you know Cp minus Cv is R. From here, when you substitute Cv is F by 2 R, Cp will be 1 plus F by 2 into R. So gamma value depends on degrees of freedom. Degrees of freedom, yeah, we don't know exact dependency on temperature. So when we go with temperature is kind of low temperature, then degrees of freedom are fixed. So it doesn't depend on the temperature. Two polaroids A and B are placed such that the pass axis are perpendicular. So angle is 90 degrees. Now another polaroid C is placed between A and B, bisecting the angle between them. The intensity of unpolarized light is, so A and B at an angle 90 degrees. Now you are putting some C in between, which is making 45 degrees. So angle between A and C is 45 degrees, C and B is 45 degrees. So what will happen to the unpolarized light when you pass it? So what is happening? So A is there, B is there. Now C, you kept C in between. So initially unpolarized light will be coming and it will be passing through this axis, polaroid A. So if unpolarized light will be coming, then it will be turning out into polarized light with intensity I naught by 2. It will become I naught by 2. Now it will become polarized. This is unpolarized. This will become polarized. So this polarized will be passing through C, which is at an angle 45 degrees. So how much intensity will be passing? I naught by 2 into cos square 45. Malus law. So cos square 45 is 1 by 2. So I naught by 4. So how much is passing through C? I naught by 4. Now again, what is the angle between C and B? 45 degrees. So how much will pass? Cos square 45 was this. So I naught by 4 into cos square 45 will be I naught by 8. So this one will be passing. Unpolarized, this will be polarized with axis along A. This will be polarized with axis along C. This is polarized with axis along B. Next question. Which of the following are dimensionless? Now, all these three are resistors only, resistances only. So, all these three will be having same dimensions. So, you can visualize all are R on R. So, this will be having R cube dimensions. This will have R by root of R square. So, it won't be having any dimensions. Now, this one will be having dimensions of 1 by R. This one will be having dimensions of R. So, this is dimensionless. 100 balls each of mass m moving with speed v simultaneously strike the ball normally and reflected back with the same speed. The total force exerted by the balls. So, if a ball is hitting and reflecting, what is the change in momentum? Initial momentum is mv in this direction, final momentum is mv in this direction. So, momentum is a vector quantity. So, when you are subtracting, you need to subtract like vectors. So, final momentum is minus mv, initial momentum is mv. So, final minus initial, minus mv minus plus mv, which is magnitude wise 2 mv. Change in momentum will be 2 mv. For one ball, change in momentum is 2 mv. So, for 100 balls, change in momentum will be, for one ball, change in momentum is 2 mv. For 100 balls, change in momentum will be 100 into 2 mv. So, change in momentum by time taken, rate of change of momentum. Force will be given by rate of change of momentum or change in momentum by time taken, right? A thin rod having length 1 meter and area of cross section is suspended vertically from one end. The rod is cooled. So, once the rod is cooled, what will happen? Its length will get reduced. Now, if you attach some mass, again its length will increase. So, they are saying like it will be increasing to the same length. So, Young's modulus and coefficient of linear expansion, all stuff are given. So, we need to find what is the value of what mass should be added so that it will come to the same length. So, these two things, Young's modulus, from here you can see what is change in length. Now, when you heat, what is the change in length? See, anyway, we have to calculate approximately. So, I will be just going with the approximate. So, I will be saying like change in length because of this thing and this thing. If it is equal magnitude wise, then it is sufficient enough. So, this change in length equals to this change in length because of adding mass and because of cooling, right? So, because of adding mass and because of cooling, change in length will be same. So, when I do that, what is the force? Force is m into g. From here, I need to get the value of m, which will turn out to be Young's modulus into area of cross section into alpha into delta t by g. All these values are given in the question. You just substitute the values and get the answer. Answer will turn out to be 60. The speed of swimmer in still water is 4. If the swimmer makes his strokes normal to the river flow, he reaches a point 750 meters downstream. The speed of the river water is. So, river is flowing this way, he is going this way with speed 4 and this is 1 kilometer given, and what is happening? River is pushing him this way. So, what is happening? He is ending up here where this distance is 750 meters, which is 3 by 4 kilometer. Now, from here you can see this angle will turn out to be tan theta equals to 3 by 4 by 1, which is 3 by 4, this angle is 37. Once you know this angle is 37, I can bring it here. Summation of this vector plus this vector must be along this direction. That's the reason he is going this way. So, yellow plus green must be equals to white. So, when I bring this green here, tan 37 equals to green by 4. Tan 37 equals to that R by 4. Tan 37 equals to R by 4. So, tan 37 is 3 by 4. So, R equals to 3. So, river speed is 3 units. 3 km per hour, because this is 4 km per hour. In the figure below, a block of mass m is placed on frictionless table connected with two springs having spring constant, same spring constant. If the block is displaced horizontally through x meters, then the number of complete oscillations. So, when you disturb it, when you push it by x, what will happen? This one will pull it by kx, this one will push it by kx. So, both are in the same direction. What is the net force? Kx plus kx, 2kx. So, when you push it, the force is going to be kx plus kx 2kx, that equals to mass times of acceleration. But if you want to write in vector form, if the displacement is in this direction, acceleration is in this direction. So, they will be in the opposite direction. So, force is in this direction, minus kx. Minus kx equals to m into a bar. This is the vector form. Now, you see minus 2k by m, a bar equals to minus 2k by m into x bar. This is a bar equals to minus omega square x bar form, that is SHM form. So, once it is of SHM form, you know the time period will be 2 pi by omega. Instead of omega, it is root of 2k by m. So, when you substitute, you will be getting this. Mass value is given in the question, k value is given in the question. So, what is the time period? 0.7 pi. So, time period is 0.7 pi. but they are asking in this much time how many oscillations. Let me say a number of oscillations. So for one oscillation this much time, for n oscillations it will be this much time. So in 14 pi time how many oscillations it will happen? 14 pi by 0.7 pi, which is 20 oscillations, right? In a medium, the speed of light wave decreases to 0.2 times its speed in free space. The ratio of relative permittivity to refractive index is x is to 1. Given speed of light in free space and mu r of the medium is 1. So refractive index will be given by speed of light in vacuum by speed of light in the medium. They said speed of light in the medium is 0.2 times of speed of light in vacuum. 0.2 is 1 by 5, so this will turn out to be 5. Now similarly, you know speed of light, how it is related to permeability and permittivity, and permeability and permittivity absolute will turn out to be relative into vacuum thing, right, by definition. Now when I separate it, 1 by root mu r epsilon r, 1 by root mu naught epsilon naught, this is speed of light in vacuum, and they said this is 0.2 times of speed of light in vacuum. So this is speed of light in vacuum and this is 0.2 times of speed of light in vacuum, they said, and this value is 1 given in the question, so 1 by root epsilon r. From here epsilon r will turn out to be 25. They are asking what is the ratio of epsilon r by refractive index, so 25 by 5, which is 5. A solid sphere of mass 1 kg rolls without slipping on a plane surface. The kinetic energy is 7 into 10 power minus 3 joules. The speed of center of mass of the sphere in centimeter per second. So kinetic energy will be having two components: kinetic energy of center of mass and about center of mass, half mv square plus half I omega square. Now I for solid sphere is 2 by 5 mr square. Now it is pure rolling, so v equals to r omega. The bottommost point velocity will be same as ground, which is 0. So v minus r omega equals to 0, so v equals to r omega. So when I substitute instead of r omega v, I will be getting this thing. Now what is the total kinetic energy? Total kinetic energy, I can take half mv square common, so I will be getting 7 by 5 into half mv square. But the total kinetic energy is this much given, 7 into 10 power minus 3. From here I need to find what is the velocity. Half into 7 by 5 mv square equals to 7 into 10 power minus 3. Mass value is given as 1. All are SI units. So when I cancel, when I substitute, I will be getting 1 by 10 meters per second. But they are asking in centimeter per second. So this is 100 centimeter. 100 by 10 is 10, right? An inductor, capacitor and resistor are connected in series with 220 volt AC source. So when they mention like this, it is RMS value. If the current is in phase with EMF, so what does it mean? It is under resonance. So under resonance, XC will be same as XL, or anyway, so Z value will turn out to be simply R. So when it is under resonance, it is going to behave like simple resistive circuit. They are asking what is the amplitude of current. So once it is under resonance, I can calculate IRMS value easily. VRMS by Z, Z value will turn out to be simple R. So this is given in the question. R value, resistance value is given in the question 20. It has nothing to do with XL and XC value because they will be getting cancelled. So RMS current is going to be 11. If RMS current is 11, then maximum current will be root 2 times of 11. 11 root 2, but they are asking how it looks when you take it into the root. So when you take 11 into the root, it will turn out to be 121. So the answer is going to be root 42. So they are expecting us to mark 242. The expression of electric field is given, the flux through the cube. So the first of all, the thing is electric field is along x-axis. So if the electric field is along x-axis, the flux will be through only this phase and this phase. And the good thing is electric field here is 0. So if the electric field here is 0, flux through this one is 0. So if you can find what is the flux through this one, that is going to be the answer. If I want to find the flux through this one, I need to find the electric field there, then multiply with the area. So electric field for this plane is 0, x equals to 0. Electric for this plane is 400 into x square. X is, this length is 0.2 square. So which is 160. So electric field here is 160. So flux through this phase is 0. Flux through this phase will be 160 into this area. That area is 0.2 square. 160 into that area, which will turn out to be 6.4 SI units. But what are SI units? It is electric field into area. Electric field will be volt per meter. Volt per meter. Area will be meter square. So this is voltmeter, but they are asking in volt centimeter. 1 meter is 100 centimeter. You will be getting 640 volt centimeter. A lift of mass 500 kg is descending with a speed 2. Its supporting cable begins to slip. That's how you will be getting an acceleration 2. The kinetic energy once it falls through 6 meters is how much? So what is happening? Initial velocity is 2. What will be the velocity once it travels distance 6? So v square minus u square equal to 2as. Initial velocity is given. Anyway, minus 2 whole square I can write. Minus 2 whole square will be same as plus 2 whole square. Now acceleration is in the downward direction, so minus 2. Displacement is in the downward direction, so minus 6. From here I need to get what is this value. V square will turn out to be 28. Once I know v square is 28, I need to find what is kinetic energy. Half mv square. Half mv square. Mass is 500. V square is 28. Right? So you will be getting 7000, which is 7 kilojoules. For a hydrogen atom, lambda 1 and lambda 2 are the wavelengths corresponding to transition 1 and 2. Transition 1 and 2. The ratio of lambda 1 and lambda 2. So what is the energy difference for this thing? Energy difference for this thing is 13.6 into z square by n square, you know. So the energy difference will turn to 13.6 into this is 1, this is 3, 1 by n square, 1 by 1 square minus 1 by 3 square. That's the energy difference when electron comes from here to here. So that will be emitted as photon of wavelength lambda 1, hc by lambda 1. Now if something goes from here to here, the energy difference will be 13.6 into 1 by 1 square minus 1 by 2 square. This energy will be coming out as photon of wavelength lambda by 2, hd by lambda by 2. Now this one I just took LCM, so 8 by 9, this will be 3 by 4. So I have taken the ratio of these two. Once I take the ratio of these two, 13.6 will get cancelled, 8 by 9 by 3 by 4. This one will be lambda 2 by lambda 1, this will be 8 4 32, 32 by 27, right. They are asking lambda 1 by lambda 2, which will be 27 by 32. Two identical cells are connected either in series or parallel with external resistance 5, gives the same current. The internal resistance of each cell will be. So they are saying whether you connect external resistance to two cells like this or like this, current in this one is going to remain same. So I can write loop equation here. Once I write loop equation here, I will be getting like E equals to total current into, current into this resistance plus this resistance plus this resistance. So yeah, 2E equals to I into total resistance kind of thing. These three are kind of series. I can get this equation by writing loop equation. So from here I will be getting the current in the 5 ohm. Now here what I will be doing is, I will be taking this as 0 potential. So this will be minus E, this will be minus E, this will be 0. I will be modifying it to see it like T-shaped figure. Now I will be assuming this as higher potential, so current will be outgoing, current will be outgoing, current will be outgoing, outgoing current will be x minus of minus E by R, x minus of minus E by R, which will be x plus E by R. Now here also x minus of minus E by R, which will be x plus E by R. Here it will be x minus 0 by 5. Outgoing current plus outgoing current plus outgoing current. That must be equals to incoming current, which is 0. From here I will be getting the value of x. But what I need the current in this. Current in this is x minus 0 by 5. So once I get the value of x, I will be getting x minus 0 by 5, which is x by 5. X by 5. I need to find what is the value of x by 5. Yeah, so x by 5. So this current and that current will be same, they said. So what I will be doing, I will be equating these two currents. I will be equating this current to this current. So this is the current in series, this is the current in parallel. E and E will get cancelled, 2 1s are 2 5s are. Now this is 50 plus 5R, I will be bringing on to the left hand side. So when I bring here 10R plus 25. So when I bring this one, I will be getting 5R equals to 25, R equals to 5. So what must be the internal resistance? Internal resistance is going to be 5 ohm, right? Thank you.